Dr. Ponwell, please mute your mic. Dr. Siba, please mute your mic.
Okay, apparently you have made me the host, so I'm back.
Yeah, I have made you the host.
Yep, so I'll minimize this.
This time, Dr. Jared, just a minute. This time what I have done is I have muted everybody, and
yes,
you cannot unmute yourself. So if somebody wants to speak, just raise your hand or just write that in the chat window and we'll unmute you one by one. Yeah.
Okay. So I will jump into the other program, which is Spartan. So Spartan, you see here is the, this is what if you install the program, you have an activation code for it too, or we'll get one. This is what it will look like the first time you open it up. So here's the little, it's just in the green screen. So ODYSSEY throws you immediately sort of in a chemistry context. Here you have to, you have to decide, what you want to do. So it's sort of an empty lab bench. But the user interface is very, very similar to ODYSSEY. If I select here now the build panel on the left side, the icon, the build panel is on the right side, not on the left side as an ODYSSEY. So probably you can handle that type of difference. Here it's the same thing if I want to build acetic acid. So here it's like a group, carboxylic acid. Here I'd done something like that earlier, I think. So, oops, I don't undo. What did I? Didn't pay attention. So here I'm in view mode of the program. I can, if I minimize here first the energy with, so I can do, I can now calculate it's one mouse click in ODYSSEY to get the wave function, and it's not, the word wave function doesn't even appear in the program. We're keeping it behind, hidden. We call it electron cloud, given the user base of the program. Lots of people, who use it, who have, quantum chemistry is far away from what they deal with. So we don't talk about, so the electron cloud is something magically, emerges. It's the square of the wave function, but so calculations, set up for the calculations, and I can here, I will, to save time, I won't minimize the structure. I will go to energy. This means we'll use the structure I just had, and then I can pick a method, and if you do your density functional, and I click OK, and I will immediately request now one of these surfaces. I will select surface for the surface for the density. I will select bond density, and I will select potential. I will select the potential with none, and I will select the HOMO, and we'll select the LUMO. And then I will submit the whole thing. This is sort of the format of a classical research program, even though our interface is a lot easier than other research programs. And I have to save the file on my desktop. Calculation starts. Now, this year I'm using here an state-of-the-art density functional with a pretty good basis set. This is no longer, it's not the best you can do, but it's awfully good. So, and I can calculation completed because these days everything is so fast. Here's the density. If I select this, I can change the style here to transparent. Here's the underneath that. Here's the bond, higher ISO value for the electron density, closer to the nuclei. If I take this one here, I can change that one, let's say here to mesh. and turn this one back on. So here you see, lower electron density. This is about 90. We can actually look up how much of the electron density is shown. We go to properties. If I go to properties and select, oh, what's the mess? Okay, zoom. Okay. I am unmuted. My video is running. So oh, I forgot the screen. Did I forgot the screen share? Okay. Yeah. So can you confirm? So I should be. So I'm not muted. The video is running, and the screen is shared. You're sharing the screen, so you should see. You can't see the program now, can you? Maybe I should check the chat. Where's the chat? Okay, all right. Okay, so I suppose, so what I had done is, and you couldn't see anything, so I had built a molecule of acetic acid, and I had set up, requested a calculation of the wave function with a DFT, with a functional, with a state-of-the-art functional, the best functional that that you can use without spending a huge amount of time. And I had then requested the calculation of several surfaces. Here was, for example, I had the density at a higher ISO value, the electrostatic potential. This here sketches out basically the lone pairs here on the carbonyl group, the lone pair here, pairs on the hydroxyl group. Electrostatic potential map. That's the type of figure that Dr. Kishore calculated, and I calculated earlier with one mouse click in ODYSSEY, and the HOMO and the LUMO. In fact, the program gives you all the energy levels, all the orbitals right away. If I go click here on this one, I can simply click on the left side. You can, I mean, these get pretty complex immediately. For something like for conjugated hydrocarbon, it's simpler than for something like that with a functional group. But so these are all available with one mouse click. I'll hide this again, and yes.
Sorry to disturb you. Can you start from beginning because nobody is following?
Okay, I'm sorry that for this mishap. So we need to have more safeguards in there next time. So I will close my acetic acid example. No. And actually I closed the whole program. So I start up Spartan again. And I will do the screen share screen with Spartan student, share. Okay, now I'm praying that you could all see as well as hear me talk about it. This green screen, which is the start page of Spartan, the way it will come up the very first time you install the program. And I'll have the chat window with the, so I, okay, if there's any problem, I have the chat window up. I will try to glance at it so that I'll see immediately what. So I can build molecules. I'd select here the build panel in Spartan is on the right side, not on the left side as in ODYSSEY, but I can build now. I build acetic acid. I do it again. Acetic acid. I select the group option here, carboxylic acid. I can build it also atom by atom. So this way it was 2 mouse clicks. Here I'm back now in view mode. I quickly minimize the energy classically. And now what I had done is I had requested my wave function and surfaces. Calculation dialog. You can quickly see the options. You have this option here of energy, which use the structure as is, equilibrium geometry, so find an equilibrium structure, transition state geometry. This sort of, you can see here, this is what you would use. I guess there was an earlier question for, if you want to do organic reaction mechanisms. And they have stuff having to do with conformers, energy profiles for reaction coordinates. So I will use the energy in the interest of time. Density functional. This here's this mouthful, but we have a lot of experience. We advocate this is the best functional you can use these days. Reasonable basis set, and I click before I submit it. I will immediately request the calculation of various surfaces. So more surfaces. I will do a density. I did bond density. I did density potential, and I did potential, and I did. I'll do do another. Actually, homo. I don't need to do this because I can simply select that later from the energy levels on the left side. So then I will submit the job. So this is like a traditional research program. I submit this. There's no running in the background. This will just run a few seconds because the computer is fast, and I didn't request an energy minimization and a equilibrium structure. It will only minimize the energy for the given geometry of this molecule. It should finish in 5 seconds. At least last time it finished in 5 seconds. You can watch it run. Yeah, it completed. Okay, maybe it was 10 seconds or 15 seconds. So here is the density, which I can show this in different styles. Here's the density, higher ISO value of the electron density, so closer to the nuclei. You can superimpose here so this here is about 95% of the density. This here is about maybe 50% or something like that. Here's the electrostatic potential, delineating the lone pairs in the molecule, the lone pairs in the carbonyl group, the lone pairs in the hydroxyl group. Electrostatic potential map. This is the equivalent of what Dr. Kishore already calculated with ODYSSEY earlier, and I did also for an example. And I can look at the energy levels. It's simply one click on the left side. And if I click here on the energy levels, I can request here the various molecular orbitals. LUMO here. Now, for something with a functional group, that gets very complicated. This here is for the organic chemistry experts. I will turn this off and show you quickly here what you can calculate spectra. If I do calculations, and I select here IR and NMR, and I will submit that. I will, and this now will probably run for about a minute, because to get the IR spectrum, you need derivatives of the energy. So that's a little bit more time-consuming calculation, but it should be run in about a minute or so. And In the meantime, let me tell you, so this program is called Spartan Student. There are two versions of Spartan. Spartan itself, it's known as the moniker Spartan 18. Later this year will be Spartan 20. So Spartan 18 is the currently shipping program. That's sort of the flagship program. There are no limits on anything. Spartan Student is a cut down version of Spartan, more targeted towards, for teaching use, even though it shares, I mean, it prepares you perfectly for using the complete program, but it has limits in terms of the number of atoms and limits in terms of the number of density functionals you can use. It's all a little bit simplified, even though it still has the flavor of a real research program, but it's simplified. You can do with DFT, this is the method I'm using right now, density functional theory, you can do up to 30 atoms, okay? So 30 is the limit. With semi-empirical, up to 75 atoms. If you want to do more, you have to use the regular Spartan. So Spartan Student here, it finished, display spectra. And here I can now, I select on the IR calculated. So here's my my calculated spectrum. If I highlight here below, I can move this here. It shows the normal mode here for the frequency. This is the carbonyl stretch, the fingerprint of a carbonyl group. So here is for these normal modes. I'm moving here. It's very, very, very intuitive interface. I'm moving here around in the spectrum to see which frequencies actually correspond to which modes. So the really high frequency ones will be, stretch modes for CH and OH. Oops. It's a little, there we go. Here's the OH stretch. Here for that's going to be the highest frequency ones in the spectrum and so on. So I will hide that and go here to the NMR spectrum. So calculate proton spectrum. So here there's a finite number of protons here in this here. So here's the one for the chemical shift for the hydroxyl group, and here's the chemical shift for the methyl group. You can calculate carbon 13. So here it's similar. It will highlight which chemical shift corresponds to what atom and so on. Okay, and to show you one final example in Spartan, I will now not do acetic acid, but actually open the molecule of this CGS 441524, which I had built with ODYSSEY. I built that with ODYSSEY, exported this as .spartan. So here's the molecule, which is now actually the metabolite of remdesivir, which is after metabolization. This is the active substance. So, and I had shown, compared that with adenosine already in the ODYSSEY compare facility. Now here we'll calculate the wave function, set up, and this is now more than 30 atoms. So if you want, with real Spartan, you can use DFT. Here I have to stick to semi-empirical PM3 because there my limit is 75 atoms. This is less than 75, so I will be fine there. So this will be okay. And I will request a surface immediately. Well, now a different type of surface. Namely, I will request density, I will request a slice, and I will request the density slice and do an okay. And then I will submit that. And that completed immediately. So, and what I have here now is, so here I have this, I can select this here. So here I'm looking at the contour plot of the electron density of the square of the wave function. If I do properties, I can select this. I switch from conc here to turn off the bands. You can see here, I can scan, I can now explore, you know, the electron density of this molecule as this is all intuitive. It's all, it's a little bit of a learning curve, you know, I'm switching here back and forth, but you have to pay attention to what is selected. But you can, I can get beautiful pictures, and I mean, this here, you know, just shows you the functionality of the program. Now I can ask chemical questions about the system by using the you know, the slice facility. Okay, so that's sort of the basic functionality of Spartan Student. The last thing before I finish this is I'll show you that this you can I can handle multiple molecules at once. If I go at once, if I come here spreadsheet, I can do this one, copy. We'll paste the molecule here. So, and I can do 2 molecules. Turn off the coupled. For this one here, I think I want to turn off the surface. So here I just copied it now, but I could have, you know, I could now modify one of the 2 and compare them. You can compare them, you know, on the screen next to, it's sort of similar to in ODYSSEY, it's 2 frames where you know, there's a dividing line in between. Here in Spartan, I can do even copy, paste. I mean, here I'm just going to do 3 versions of the same, but I can have as many as I wish. Teaching application would be if I, for example, you know, if I, you know, compare the acidity of 3 different acids of different acid strength, you know, acid A, B, C, that can easily be can all be done at once by using the spreadsheet of the program, which is where you can even if you go to this calculations dialog, you can run global. If this global, it will do the wave function for all 3 of them at once, and so on. So it's power use of the program allows you to do complex operations as easy as you can possibly do it with any quantum chemistry program. And learning it with Spartan Student, you're fully prepared to, you know, to use it with the real Spartan, where there are no limits, and, you know, use it for hardcore research in organic chemistry, medicinal chemistry, whatever, physical chemistry. We've now gone 2 hours and 7 minutes, and we should have another opportunity to answer questions. I'm looking at the chat window. Yatindra said to unmute everyone. Another possibility is if you were, can you address the chat directly to me, Jürgen? That maybe I can read off the question from the chat window. Or we try to do it orally. Maybe I go, should I make, I make Manoranjan the host.
Okay. Thank you, Dr.
Because
Jacob.
you seem to be better with handling, you know, the microphones.
No.
Yeah.
Okay. Now
Well, I can.
Okay. I request everyone, those who want to ask any question, to please write it in the chat window.
Okay, please. Okay, can we save the coordinates? this was, of this molecule and export it into another software to do some calculation. Yeah, in Spartan, I can read off because I'm no longer sharing, I'll just see, I go to.
No, you can share your screen. Your screen is still shared.
Yeah, okay. Okay, you share, I'll share, okay. So I'm screen sharing and so I have a model, I go to save as, and let's see, the options are Spartan, SP input, text, SXF, Spartan exchange file, chemical markup language, CML, macro model, Sybil, PDB, XYZ.
So almost we support most of the file format for the tools available.
All standard stuff. XYZ will always get you to anywhere you want to go. Next question, can we extract the computed IR to Excel file? Yes, you can. Sir, existing molecule only doing, no, in ODYSSEY, the question seems to be, can ODYSSEY only do existing molecules? No, the ODYSSEY comes with about 1,000 compounds, 3,000 models that are pre-built, but it has the full build functionality that you see also in Spartan. You can build anything from scratch. There are no limitations. So it's an open-ended program as well as a program with targeted content. Is there provision for TDF or CI calculations? For that, you'll have to move on to the regular Spartan. This is really a tangent for teaching use. Regular Spartan will get into that. In the most complex or the most high level stuff you will see in Spartan Student is MP2. So, but TDF, going beyond that, you will have to go to regular Spartan. And other questions, or alternate, maybe Dr. Kishore should wrap it up, or.
Yeah, Dr. Shyam Kishore, I think you can have a wrap-up discussion. And I think today's session is we can plan for some future sessions also. Dr. Shyam Kishore, please come to the desk.
I just see, am I still on microphone? There was one good question. Can we predict reactions? Yes, there's actually, there was, even maybe I didn't draw your attention to it. The dialogue, the calculation dialogue, there was the last entry where it was energy, equilibrium, transition state, and so on. Transition state, of course, already leads towards reactions. The last option was reaction profile that leads towards reaction coordinates. This is the great strength of the program. It will make it easier than any other program you can get. Still, this is not a beginner's modeling reactions. Yeah, but it's not a beginner's operation. So it's something that you want to do after you have become comfortable with the program. You don't want to do this in the first hour you are ever using the program. There's some learning curve there. Okay, then maybe Dr. Kishore.
Thank you, Professor Jurgen. We had a long session now. We got really a lot overview of this both ODYSSEY and Spartan. So for the participants, we'll share all the recorded session there with you. So please go through them. And again, I'll repeat, for the assignment, again, no doubt we'll send you all the information through email also. But just to say that simply you have to practice both those software with some simple molecule and share your results with us. We just want to know that have you practiced these two software or not. Obviously, it's not easy to master at one go, but just start practicing it. You have 1 month license with you. And then if there is any query, you can again talk to us. We have now a WhatsApp group again. So through the WhatsApp also you can share your concern. And I think I'll tell you that it's ultra easy to use, means it's very user friendly, especially the Odyssey is very user friendly. And my suggestion is that use it for your lecture also. And I assure that your lecture will go to the next level. So let's thank Professor Hagen, and thank you all the participants for participating in this workshop. And I hope that it was useful. So Manojendra sir, let's wind up this meeting. It's already 2 hours long now, and it must be a late night for Jürgen, sir.
Yeah, we are a little bit after midnight. Yes.
Yeah, sorry, sir. We have taken you a great ahead.
It was a pleasure. So thank you for listening, and have a good afternoon.
यही तो कह रहे हो.
All the participants, thank you all of you
Close the meeting
making
now.
this today's event successful. We are ending the meeting now.
पहले मैं क्वेश्चन देखूंगी, फिर मैं आपको मेल करके फिर बात करती हूँ. बच्चों का कब का बोलना है? 15 तारीख का. कब बोलना है? 20 तारीख के बाद. वही नेक्स्ट थर्ड वीक में ना.
क्या करो शाम को रोटी नहीं बनेगी क्या? शाम को चावल हमारे घर में भात ही नहीं होता.
Dear participants, now we are closing the meeting, and you will get the mail from us regarding the download link for the software along with the trial license. So for the certificate, as Dr. Syam Kishore explained, we will wait for the feedback of on both the software and what is the assignment you will do by your side, or we'll say some assignment for you. So thank you all for joining us and making today's event successful. Manoj sir?
So we are ending the meeting. Participants, thank you so much for your time.